Hello, everyone. Today we're going to start the last part of Aero 307 or 489, which is the aerospace labs. In this lab, we want to talk to you about, we want to educate you on the basics of the design of the experiments. And it would be very good if you can learn the contents of this videos, these set of videos, and retroactively go back and look at the experiments that we have done throughout the semester. So I am going to share with you these slides that you also have a copy of them that you can go back and forth and look at the slides and the videos. The majority of the slides are prepared by Dr. Nathan Tishner, and I've contributed to it a little bit as well. So, I mean, first things first, what do we mean by an experiment? So what do we mean by an experiment? Experiment is basically a relationship between two things, input variables and our desire to relate them to some output variables, which is of interest to us. And so basically we want to draw a connection between these two. And typically, the way we want to do this is the reason we are doing this is because we are trying to answer some important questions. For instance, as an example, we want to know how the forces that are applied to a material force, a solid, changes the shape of the solids or the deformation of the solid. This is what we want to identify the relationship between these two. And in doing that, basically our variable of interest or output of interest is actually the deformation, but in this case we want to relate it to force. So a source of variation of the deformation is force. Force deformation can change if you change force, but at the same time there are other variables that can input that can change this deformation. For instance, temperature is one of them. The other one is the geometry of the material. Okay. And the other one is the geometry of the material. So the question is, in designing the experiment, we first want to identify the real question, which is in this case, how deformation is related to force. We want to identify all the source of the deformations, which in this case is not only force, it's also temperature and the geometry of the sample. We want to see under what conditions do we need to run the tests so that with minimal costs, we can identify this relationship. And the other thing is, we also want to, which is related to the costs, is how do the data need to be analyzed, or how do the data need to be compared with existing data, or how does it need to be normalized so that we can use the most out of it. For instance, if I, in identifying this relationship between deformation and force, imagine I have, I take a block of aluminum that is, aluminum that is this size, and I apply a force to it. So I apply a force here, and I apply a force here, and I measure the deformation of it. I can report data, I can analyze the data in certain ways, in many different ways. I can, let's say, if you want to change the shape of this guy by 1 millimeter, elongate the sample by 1 millimeter, you need to apply this much force. That's one way of reporting or analyzing the data. However, there could be other ways that would allow me, for instance, to learn from this experiment so that I can make predictions about how this other sample will deform. This is all concepts about analyzing the experiment. So what is the scientific question? What are the sources of variation? Something about the cost of the experiment. How many tests do we need to run? And under what treatments or under what conditions do I need to test this? And how will the data need to be analyzed? And we do these experiments with two constraints in mind. We want to answer the question, the scientific question we have, but there are two constraints that we have. One is we want to maximize the probability of success, which means here success basically means addressing the question. At the same time, we want to get the maximum amount of information from the experiment. And what I mean by that is, for instance, if I test a sample that has this geometry, can I use this as a basis to calculate the deformation of a sample that has this geometry or this geometry, things like that? How do I need to present this information so that I can test these other geometries? And so in designing the experiments, the other thing we want to do is we want to minimize other sources of variations. You remember I told you we want to see for a deformation F, for a force F, how much the sample will deform. Well, if we know that the deformation also happens by changing temperature, so in this case, I am going to keep this constant so that all the changes in deformation that I see happens because of the force that I apply to the sample. And the other thing in designing the experiments is minimizing the cost. A lot of times, cost, there are many factors that, there are many things that factor into cost, such as the number of experiments. If I have to run an experiment 5 times versus 10 times, the 10 times will cost me twice as much probably. What geometries or what sizes of the sample can I test so that I can get away with the instruments that I have? Things like this. Now, in these experiments that I mentioned to you here, especially something like this, the input and the output are well defined, and I have some control variables that I keep constant. But, and this is the typical experiments we do in engineering. So basically, in this case, the input that is changing. I have one variable that is changing. I have one output that I'm measuring. And there are many other influential factors that are sources of variation, such as temperature, that I keep constant. An alternative to that, though, is another set of experiment, which happens a lot of times, not a lot in engineering, but a lot of times, for instance, in social sciences, where the researcher, does not control the sources of variations. For example, imagine we want to see how is people's income related to their degrees, educations. So in one case, we have degrees, and we want to see how that is related to income. Now, I can look at 10,000 different people. But the thing is, each of them will have a unique combination of gender, age, social backgrounds, and many other things. So now some sort of averaging can be done, some sort of correlation can be evaluated there to identify if the correlation between these two is positive or how positive that is. But in engineering, we're not going to deal too much with this type of experiment. So I'm going to pause here and start with the next video.